And welcome back. Now I've been on holiday recently, and in my absence I've had these lovely items all appear in my post box, which I've managed to acquire through one method or another. So I'd like to look at them all in some detail, but only one video at a time, so I've got to make a decision. What have we got here? Well, this one over here is in fact not an Arduino, but it is an ESP based board. This is an ESP Rover. At least I think you say it like that. ESPW Rover, wireless Rover. Anyway, it's an ESP chip on a board for development purposes. It's got something like an SD card on here, and on the back it's got this rather gorgeous, quite large screen. So that's one thing I'd like to look at, because I know that ESP type boards I've been neglecting of late. On this side, it's a lovely little set of kits for expansion and development use. Now these are made by Awesome PCB over in Poland, and Simon over there has sent me this whole gamut of stuff here to look at. So I'll look at some of these. We can't possibly look at them all, not even in a whole video, but we'll look at some of these and see how much they can help us Arduinites going forward. And then finally we have this item at the back here, which you can't really see that well. It's from Banggood, and it is in fact an oscilloscope kit. I probably can show you these on the browser a bit easier. So let's switch over to the monitor and have a look at each of these in turn, and then we'll decide which one we're going to tackle first, because I've got to do all three. So we'll take a random pick, I think, at the end of that. Right, over in the browser then, what's the first one? Right, so this is Awesome PCB, so these ones down here. Now as you can see, the idea is that it holds any number of boards on here. So we can put the Uno on, the Nano, the Micro, the Pro Mini. All of these fit onto this one single board, and this is called the Ardu Shield. And well, it looks interesting, so that'd be quite interesting to look at, I think, for everybody. Well, the second thing is then this is the oscilloscope kit, and that's not expensive, as you can see, and it does come with a screen and a board and a few kits of parts and things. And I thought, well, this is something that a budding Arduinite might well want to build up. Now let's not get too excited about this in terms of functionality. It's not going to be, 100 megahertz oscilloscope. This is for, low level stuff that you might want to use when building Arduinite type circuitry. Not Arduino boards themselves, but the things that go around them. So it will probably measure up to about 100k, I should imagine. I haven't really checked into it, to be quite honest. But it does come with a case, as you can see there. So it is self-contained, and of course can be used for any electronics. But I think that might be quite interesting for us to have a look at. And finally, the ESP32 Rover. Now this website here, in fact, is Olimex, and they sell a load of stuff. But as it says here, this is not produced by Olimex. It is in fact Espressif, who make the ESP chips. So in fact, if we nip over to the Espressif site, it shows you here, and it gives you an overview down here with various bits and pieces and various resources. Now, yes, you might have just noticed that it talks about built-in USB JTAG debugger. Now that could be of interest to people who want to debug their code in a little bit more detail, and of course this ESP board will be able to contain quite large programs, so debugging is ever more important. Now JTAG, which is what it mentioned down here, ESP JTAG debugger, there's a nice little site on here, how to make use of it, so that's something else we can explore as well. So the question is, which one should I do first? Well, to be absolutely honest, it's probably fair if I take them in the order that they arrived, because they all need looking at. And the ones that arrived first were these ones here. So the Ardu Shield, and in fact all these other bits and pieces from Awesome PCBs. I think it's probably fair's fair, and I'll do this one first and do these two other things in future videos. So at least you've got a preview of what might be coming up over the next few weeks. Right, okay, let me clear the desk, and well, we'll have a look at this in a bit more detail. And here we are back with a simple little circuit put together to demonstrate what it is that Simon's hoping to achieve with his awesome PCB boards, and in particular this one here, which is the Arduino Shield. So what I've done is put together a little circuit, which I must admit I blatantly copied to a certain degree from his website. Well, after all, you know, can you improve on perfection, or indeed reinvent the wheel? So let's assume then we have a typical sort of circuit that the Arduino Uno is driving. Let's connect it all up. It doesn't really matter, to be quite honest, what the circuit's doing, but I will draw it out for you just so you can understand it. Now, as you can see here, first of all, there we are, off it goes. If I hold that at an angle, you'll get a better idea. So it's something that perhaps if you're just starting off in the Arduino world, you might think, oh, look what I can do, because it's quite an exciting thing to be able to do, to control a series of lights like this. And of course, people can then see something happening rather than just taking, you know, temperature measurements or whatever. So this is a flashy little bit of lighting, very nice. It's supposed to be in sequence. I think I got one of the cables in the wrong place. It doesn't matter. However, as I said only recently, I think it might have been my last video or the one before that, sometimes you just have too many cables to be able to see the woods for the trees. Let me just show you that. It does look like there's a lot of cables here because, well, there are a lot of cables here. I can't get away from that. So there we are, you see. Sometimes it does happen. You do seem to have a lot of cables. So what Simon's saying is, look, we can do better than this. When you're developing stuff on a breadboard like this, rather than having all these cables from your Uno, or indeed your Nano, or whatever it is board you're using, let's make it easy on ourselves and dispense with this. So what we're going to do, first of all, we'll disconnect the power, because I'm a bit uneasy about disconnecting stuff that's still running, and we'll just basically take all these cables out. So that's the power. These are all the ones that connect the LEDs to the Arduino sockets. Sort of a fairly random set of pins I chose there, I must be honest. And the idea is you take your Arduino Shield, and this plugs on top of an Arduino Uno in this case. So if we plug that in there like that, I'm just going to have to take myself off picture here so I can actually have a look underneath. Right, so there we are. That's plugged in to there like that, and including the ICSP pins on there. And then what we want to do is plug this now into this breadboard, which in fact this breadboard was supplied as part of the stuff he gave me, but I don't know if it comes with it as a kit or whatever, but we'll come on to that in a little while. So now this then plugs into this board, so that the power pin's going at the top, and these ones straddle this gap here. So that's one of the advantages straight away, isn't it? Because it only uses one row here and one row here. Compare that, say, with a Nano. If you were to put a Nano on here, look how many pins or rows that takes up, because that's going to take up 3 rows, isn't it? So you hardly have any room here to do anything. So that's one of the advantages he says. Right, so we put that on there, put the power in, and give it a few seconds to initialize, and there we are, off it goes. Look at that. So that sort of is the basis of Simon's thrust in his business, to say, look, we can get rid of all those wires, give you a lot more room on the breadboard to put your stuff in, and dispense with all these things that basically get in the way after a while, especially when you have too many of them. Brilliant. Now that's step 1 then, if you like. Now step 2 is, not only does this plug into an Arduino Shield like this, as every other shield would plug into an Uno, so basically on the top, this also has room and within it to say, look, I can also take in here a Nano, I can take in a Mini, well, all these ones, you can probably read it as well as I can, the Leonardo, Zero, but I haven't got all those boards so I can't test them all out, but we can probably try a couple. As you can see, I've got a few lying about. So if we disconnect this from the Uno, let's take the power off first, so we just unplug that from in there. Now I don't want to damage the Uno, so we just put that to one side. Right, so there we have a blank board now. Now if I was to plug in, say this is a Nano, and I use Nanos all the time as you know, the Nano fits into this one here. It'll leave a couple of sockets free at the end, but let's do that, shall we? Just line them up, put them on, plug them in, there we are. Now that obviously needs a different power supply, so we'll have this and the adapter that goes with it. It's a pity they never actually put a micro, isn't it, on the end of a Nano. Then we wouldn't have all this faffing about to do every time, but there we are. Okay, so that goes in there. That one plugs in here somewhere. There we are. So what do we get? We get a flashy light. And there it is, it's off again. Yes, of course, I've downloaded the same code onto here as I had on the Uno. So, but it proves that it works exactly the same way. I haven't changed the pin numbers or anything, they're all the same. So as long as you've got the same pins available on your board, it should indeed work. So there we are, that's great. I'm looking forward to using that, because I use Nanos all the time. What else have we got? Well, disconnect the power, take this out. They're a fairly tight fit as you would expect, and of course being new. Now this one here, this is a bit of an oddity, and one which I didn't have success with. I've written on here, this is my own little cobbled together sort of shield, I suppose you'd call it, or development board for this particular one. Now it says on it, as you can read it there, it actually says Pro Micro, but it's a SparkFun Pro Micro, which is nothing to do with Arduino themselves. So on it I've written Leonardo, because that's how it identifies itself, as a Leonardo. Now that means it's a non-standard Arduino size. So even though this fits into this board up here, nothing happens, because this is meant for a mini. So that's one board that doesn't work because it's not an Arduino type board. However, I do have here a proper kosher Arduino, what is it? I think it is a mini actually. Let me just double check that. Now look, these are the two boards. You can see how similar they look. That's the Nano that we've just been using, and that's the Arduino Micro. You can see they're very similar in size. I'm not sure they even make these anymore, but you can still get hold of them by the truckload. So we'll put this in next and see how that looks. Right, so now this time it does take up all the available header sockets on this board. Now the reason you're thinking, my God, you're making a cack-handed thing of putting that in, and as you can see it doesn't fit because I got it wrong. It's because I'm trying to do it on camera. There's no depth perception. So let me just come back in just a second when I've pushed this in, and we'll continue. Right, so here it is now centered and inserted correctly. Right, so there we are. So that's the Arduino Micro board. Let's power that up now. Once again, that's got yet another different power supply. This is in fact a micro USB. So which way round is that? That's the small to the bottom, so that goes round that way. There it goes, and well, immediately that starts running out, no delay at all. So there we are. That is also running exactly the same code. I'm fiddled with that. There's no smoke and mirrors. And well, there we are. So we've tried a Nano in here. We've tried a Uno. We've tried this Micro. I haven't got anything else that fits in here. So well, that one does fit, but it doesn't work because it's not an Arduino board. But it does show the range of boards that even I have that fit quite nicely. And there's one other which I haven't actually tried out yet, and I'm not going to because we've covered it in some detail in other boards. So let me just get this one out and we'll have a look. Right, so as you can see when I've taken that one out, there's room here for an ATtiny. Now the reason I'm not going to fiddle about with it is because as you see it is between these two header sockets here, so it's going to be quite tricky to get in, and more importantly trickier to get out. Yes, you can use those tools that I used in the other board that I demoed, I don't know, a few videos ago now, programming the ATtiny 85. This does allow that as well, but well, I think we can take it as read that the AT-Tiny85 will fit in there and it will work. Of course, it won't work with these pins because I just happen to have chosen high pin numbers, so 13s and all that. The AT-Tiny is only going to have a couple of pins exposed down here, well, 1 through 6. So okay, so that's that. Now, what else can this board do then, apart from just plugging in your stuff? Well, there's a couple of little things. Firstly, there's the I2C pins are made available here. So you've got your SDA and SCL. Let's have a look. There we are. Look, 5 volts, ground, SCL and SDA down here. And we have up this end here a rather nice multicolour LED that we can use. In fact, well, let's just prove that works, because when you're playing about with LEDs, especially the NeoPixel type LEDs, which is what this is, RGB, it can be sometimes quite useful just to have one just to play about with on the board, because you don't need a whole set of them. Okay, let's do that next. Right, so what I've done is uploaded a simple sketch. In fact, it was my NeoPixel sketch, and all I did was say I've only got one LED, which sounds ridiculous, doesn't it, when you're working with NeoPixels, because normally they come in strips or circles or something like that. So I've just said, right, I've only got one. Now, if we look closely at the board here, and I've actually got my little pointer now. So this multicoloured NeoPixel, it says LD2 out, and it's got number 8 next to it, and the 8, as I worked out, I'm a bit slow in these sort of things. If you look down here on the pin out, it says pin 8 LD2. So by that clever bit of Sherlock Holmes reasoning, I figured that pin 8 was in fact the LED out. Well, you have to try these things out, don't you? So all I've said is go and display some random stuff. So that's flashing because it's pin 13. That's just the start, and what we should see on there we are, is the multicolour LED working. So there we are, green, red, purple. It's just cycling through various colours. Great, so that works as well. Now, it's useful to have something like this on the board. I mean, it doesn't have to be working in NeoPixel mode, but when I was working with my strip and circle of NeoPixels, I always had to make sure that they were connected up properly and working for the entire strip. But this just makes it a little bit easier for prototyping, doesn't it? It's just one of those little extras we have on there. I'm back to the Uno, by the way, because I figure most people are going to be using that. And as you can see here, not everything is connected up either. Now, if you had some kind of, well, I wouldn't say criticism, but certainly a caveat, is that when you're taking these boards in and out, and that applies, I suppose, to any shield, whether it's the nanos or the micros at the back here, to get them lined up properly every time can be quite a challenge. And more to the point, when you take them out again, you have to be careful to sort of rock them and pull them straight out. Otherwise, you do end up with this sort of thing where pins are not quite aligned. You push them in, you think they're in, and wonder why your program doesn't work. So really, it's just coincidental that this program's working here. Yeah, there we are, you see. Anyway, so that's another little plus for this board. Now, obviously, what Awesome PCB have sent me is their entire range, it would appear here. So I'll whip through some of these, but we'll have a look on the website first, because if you're interested in this comes in 3 forms. You can either have just the PCB, so the white thing that you're seeing here, without any of these header sockets and pins, because, well, you might have those or want to source them elsewhere. You can also buy the complete kit and then solder in all these headers and things for yourself, which is probably the route I would choose, quite frankly, just to make it easy. Or you can buy it ready assembled, as in fact this one was. But of course, Simon from Awesome PCB sent me this one just so I could get on with it, really, rather than putting things together. And I think you've seen me solder things on boards enough now not to worry about that. But the price is quite different. So let's go over to the browser and have a look about costs and things just for this one board for now. Right, that's the home page for the Arduino. Is it Arduino? Okay, well let's move on. Products. There we are. So we're looking at the Arduino Shield, Ardu Shield, and they're the 3 options that you have. So the PCB alone, the one in the middle, oh, it's on sale, look. £7.49, that's euros, by the way. Well, these days, pound and a euro is almost the same. That's the kit of parts with all the headers and pins and everything else, £12.77. Now, I would say the difference in cost between these two is little enough to make you want to get the complete kit of parts. Cause, let's just click on that to see what it shows us. Here we are, look. So it gives us the header pins, the sockets. What about the little LED that's probably in there somewhere? Well, it gives a complete list here, look. So I'd say, yeah, that's probably a good way to go if you're an Arduinite and want to make your own stuff. Just go back one and have a look. So this is the assembled one. That's €25. That's quite a jump. Well, it's double, isn't it, compared to the parts, because you're paying somebody to do the work for you. So, yeah, I probably wouldn't go for that myself. But, of course, if you're just buying a kit for somebody, say a youngster, who isn't going to be brilliant at soldering, you know, a 10, 12-year-old or something, you think, look, let's just get the thing that works. Then I suppose this could be a nice little present for them, you know, give them that and they can play about to the heart's content. Resources, by the way, there are schematics and things and detailed assembly instructions and all sorts of things on this website. In fact, the website as a whole for Awesome PCB is pretty good. I'm quite impressed. It covers everything. Perhaps in some ways it overloads you with information because there's so much to read, but as long as you can focus on the bit that you're interested in, it's really nice. It does contain lots of these PDFs and things, exactly what you should be doing and how to assemble things. And funnily enough, let me explain how I even got into this. After I was looking at the Tiny 85 programming shield that we looked at a little while ago from Themis in Greece, this popped up. I think Google sort of realised I was looking at certain things and suggested I look at this one. And I did, and I looked at it, and the first thing I noticed were some spelling mistakes in the web page for their own product, which I thought would put people off, because I could see that the product itself looked pretty good, but spelling mistakes do tend to put people off, don't they? Now, having said that, anybody who's bought anything from China or the Far East will know that spelling mistakes are in fact a fact of life when it comes to descriptions and things, and in fact English itself is, well, stretched sometimes to the limit. Oh, saved by the bell. So anyway, I thought I'd just drop Simon a line to say that he had a few spelling mistakes, for which he was quite grateful for me pointing out, I think. And that's how I got to know about Awesome PCB, and he got to know about my YouTube channel, and that's why he sent me the stuff to evaluate and to do a video on. So there we are. That's how it's all come about. Good. Right. Let's move on then and just have a very quick look at some of the other products that he sent me that are sort of along the same lines as this, but allow more flexibility in other Arduino-related things. Right. Let's do that next. Now, if there's one type of module that I've neglected, much to my own disappointment, is the ESP range. So I was pleased to see within this kit there is in fact an ESP8266 Wi-Fi screw shield assembly. Now this isn't the same, of course, as the Arduino sized ESP8266 modules like the D1 or the ESP Arduino. This is this little tiny thing here, and the idea being that you can fit an ESP826601 module on here, which I just happen to have here. Now these are cheap in themselves. This is also cheap, so by plugging this into here you have yourself almost an instant way of developing for ESP8266 times things, you know, Wi-Fi and whatnot. So let's have a look at the website and see what Simon has to say about that. Right, these are the three things he offers then. So you've got the PCB alone, and if you've got all the parts, that's fine. But me, well, I'd probably go for the set of parts as well. However, this is interesting. Unlike the Arduino shield, where the assembled cost was significantly more expensive, here it's not. Look, so you got €5.49 for the set of parts, but only $7.89 with it all soldered in together. So unless you particularly like soldering header pins and whatnot in there, in this case I'd probably go for the assembled version. Anyway, let's have a look at that then and see what he has to say about it. So this is the set of parts you get. You get the PCB board, a few switches, these green screw terminals. What you don't get, of course, is the ESP 82601 module, but they're cheap anyway. Let's have a look at that on eBay. This is just a random search I did on eBay. There's one look. So that's 195. That's probably about the same in euros, €2, and probably about the same in dollars these days as well, actually. So they're pretty cheap and they're great things to play about with. So there's the schematic. And I've noticed on this site, the awesomepcb.com site, every single item that he's selling here, all these PCBs and kits and things, they all come with a schematic, so you can work out exactly what pin does what if you're not too sure, which is a great thing rather than some anonymous thing from China. So on this then, what does he say? He says you get a built-in power supply for your ESP8266. Don't quite know what that means. Let's have a closer look on here. There's the regulator at the bottom. So what does that take in? Let's have a closer look. Whoops. Let me just put a torch on that, get a bit more light on here. Right. So that's a 3 volt by the looks of it. 3 volt amp. Very difficult to get in here. Here we are. So where it says VCC on that board, so we're talking about this point here, VCC. If we turn that over, that's up here. So I'm guessing you supply that here with 5 volts and then it translates that down back to 3.3 for you, which you can then tap off on here if you need it for other things, but also supply this. Pretty sure that's what it means. Well, there we are. Look, VDC 5 to 12 volts. In fact, that's brilliant. It's a nice way of using these low voltage devices. Right. Okay, that's that sorted out. Yeah. So these just plug in, a bit like the NRF 24L01 transceivers, and well, this is a transmitter and receiver, isn't it? Its own little way. Great. You know, I'm going to stop trying to plug things in. Viewing it on camera, you have absolutely no depth perception and it just looks rubbish. Well, it makes me look even more rubbish than I am, I know. Yes. Anyway, so that's that. What else was I going to say about this? Yeah. So he does actually detail why this is a useful little device, and of course all these screw terminals makes plugging things in very quickly. You could put a DuPont cable in here and plug it into a breadboard or something like that. Yeah, great. Okay. Now there's one more item that Awesome PCB do, and it's a subject that's become closer to my heart as time's gone on, and that's the ATtiny 85 board. So let's have a look at that next. Right, so once again he does the PCB, the kit of parts, and the assembled one here. 580, once again the assembled bit isn't that much more expensive than the kit, but let's have a look at the kit because that's what I've got down here somewhere. Right, so this comes with that PCB, all the header pins, and in this little bit of foam here there is an ATtiny 85 and in fact a socket in the other one. So, and now the big thing about this is that the width of this PCB when you're developing stuff is the same size as this one here, and the whole point is that it only takes up one row top and bottom of this breadboard. Now the point that Simon's making here is that if you were to use a nano or anything like this and put that on there, it's going to take up an additional 2 rows coming this way, an additional 1 row at the top, simply because it's just so wide, isn't it? Which leaves you very, very little room to do anything else other than put in a DuPont cable, really. So the fact this is kept nice and small means that you can experiment with this on the breadboard and probably have enough room to do most things. And the other point he makes, if we go back to the browser window, is that when you've developed this and you think, well, now's the time to actually include it in a circuit, you can just leave this item in situ, as it were. It's not so expensive like it would be for, say, a full-blown Uno, or even a Nano, really. Sometimes a Nano can be well overkill for what you want to do, and I know there's lots of opinions on the videos that I've done my ATtiny 85 stuff for. Some people are for, some people against, but everybody's got their own preferences, haven't they? But you can't argue that one of the advantages is that if you're developing for an ATtiny 85, as he shows in the web browser here, is that it's small, it's cheap, and if this is enough for you in terms of power, then you can just plug this in and leave it in situ. This particular board can be constructed two ways. This way is for through-hole technology, and this way, that one, is for surface mount. There's the surface mount pads and things. Now, if you've never soldered surface mount stuff, this could be an interesting way to start. It's certainly trickier than with through-hole technology, because you have to hold the component in place and then apply some heat, and well, you just got to get that one pin on first to get it stuck, as it were, in place, and then you can do all the rest of the pins. But it's this is a very small board, and I'd imagine it'd be quite easy to solder. So you can have a look at the website and see which way you prefer, really. Now, he does actually include in the stuff he sent me lots of PCB boards where I can experiment with surface mount stuff and through-hole technology, which I haven't tried out yet, obviously, because I have no need at this very second. But it's interesting that he's recognised that you can get a much smaller and more compact unit by using surface mount technology for everything, really. And in fact, I would say most commercial items these days are, of course, surface mount. You just don't need that through-hole technology anymore. Well, you do, in the sense that if you've ever noticed, in fact, there's a good example here, look. On this board here, let me bring it as close as I dare. You see those two tiny little holes there? That's what they use now to bridge various layers of the PCB. Not these, well, relatively large ones for which you put components through. So surface mount technology just needs less space. So if you consider those two holes there, that little tiny one does exactly the same job as that big one there, except that big one has to be bigger and therefore take up more real estate because you need to put a component lead through it. So that's why surface mount technology is really taking off, but it is trickier to solder, and we'll be talking more about that, I suspect, in another review of mine coming up shortly. Anyway, so that's one of the advantages he says. It's small, it's thin, it fits on a circuit board like this. And by the way, this breadboard is exactly the same as the ones that I normally use like this, except of course it's double length. Apart from that, it's identical in every respect. Finally then, let's just go back to the browser window, just make sure I haven't missed anything. Oh yeah, that's the through-hole technology, that's the SMD side, we've covered that now. And I would say if you're going to try surface mount technology, do make sure that your soldering iron has got the absolute finest tip possible. The one I've got for my Antec soldering iron actually is so sharp it comes to a point, and there's a little bit of plastic on it to protect that point. Now, I've done a video on that a little while ago about some soldering stuff, including that particular soldering iron bit, and I've had reasonable success in using it. It's still tricky, because if you look at this this bit here, I mean, look how thin those pads are on here. So it is something that you need good eyesight for, or a magnifying glass, and a steady hand. So if you haven't done SMD type soldering before, and you're not particularly good at the through hole stuff, stick to the through hole until you've got that mastered, and then you can move on to SMD. Just my tuppence worth of opinion there, really. Right, I think that's probably about all I want to say on this one here. He just goes on to show some examples. But if you look at this website, it is wonderfully documented exactly what pin does what. And I must admit, I was impressed when I saw it the first time round, spelling mistakes notwithstanding, which he's now corrected. And I think, yeah, he really does know his stuff, which is why I agreed to do sort of demonstrate, if you like, his products here. Right, I think we've sort of come to the end of this, because I can see the time clicking by. And what should have been a 10-minute video turns out to be a 20-minute plus video, doesn't it? So there we are. I think we'll leave it there. Remember that his site is Awesome PCB. If we go to the home, it shows all his stuff all nicely put around. There we are, look. That's all his stuff there. He does do some other products that we haven't covered here, and in fact he's sent me some stuff amongst all this bit here which I can't possibly cover today, it'd take too long, but I think you've got the flavour. If you like this sort of stuff, I think you'll probably go to his site now and have a look. And he's in Poland, by the way, so it's a pretty quick delivery for anybody in Europe. I don't know how long it takes to get to the States from Poland, but it's still going to be quicker than China, I would have thought. with their 4 to 6 week delay. So there we are. Okay, I'm going to leave it there. Yes, this was a promotional video, really. Not that I really get anything out of it other than a free shield. But I like to see entrepreneurs really who do their stuff and really have a passion for what they're doing. I like to have a bit of exposure. And I think, yeah, this Simon, he certainly deserves that. So there we are. That's where we're going to leave it today. Great. Now remember, the beginning of this video spoke about 2 other products that I've got lined up for review. And they're coming up probably next. Well, next video. I'm not going to say next week, because as I've learnt to my cost, things don't always pan out like that. I went on holiday for 3 weeks and ended up missing about 5 videos. So we'll just see how it goes. All right, until the next time then, have a look at Awesome PCB. Thanks for watching and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.